Hey guys, welcome to an interesting video, I hope. Today we're going to be doing some guitar pick experiments, but not in like a typical let's try a bunch out. We're going to try to make one. So recently I was turned on to these Gravity Sunrise big mini guitar picks. They got this really cool angular shape, they feel really nice, they're made of acrylic. This particular one is 1.5 millimeters thick, comes to a pretty jagged point, and it's got these kind of neat bevels on it. It just feels really good. I got it in like a random lot of picks just to kind of try out, and I wanted to buy more of these because, as you know, if you play guitar, if you drop it, it goes into the void and you never see it again, and that's kind of risky when I only have one. But although I was looking to buy some more of them, and then I found out this. They go for about $5 a pick, which is pretty expensive for one pick. So I thought, why not introduce one of my other hobbies, 3D printing. As you may be able to see on this really messy desk over here, I have a 3D printer. And while I probably can't, I can't print it out in acrylic, but I can print it out in PETG, which is a very tough material. It's also see-through, which is kind of cool, kind of fits with this pick. This is also a see-through green. So yeah, let's just let's get 3D modeling. Okay, so what we're looking at now is Fusion 360. It's a program used to design and model 3D objects. You can do 2D objects as well. It's got a lot of features to it. I'm far from an expert on it, but I think I have just enough knowledge to make this pick. They do offer like a free hobbyist version for like a year or something like that if you want to try this out yourself. I definitely encourage it. It's a lot of fun, very handy. So first thing we're going to do is I want to make the top point. So we're going to use this 3-point arc here because it does have the two kind of sharp edges and then a curved top. So I'm going to use a pair of calipers to measure out this to be about 26, yeah. A little bit more than 26, actually, about 26.7. So let's zoom in a bit here, see what we're working with. So we're going to go about to it. It doesn't have to be right on the money. Let's go a little bit higher typically and just drop it a decent size arc. Now we're going to measure it, and I find the easiest way to measure is with reference lines. So I'm going to draw one across the bottom, and then I'm going to find the center point. You see it kind of snaps to that X there. And then that center point will be matching. Then we use this handy dandy dimensional tool. So with that we can select the lines and set like specific sizes for them. So like this one we set 26.7 and it will scale it down to that. And then this from top, it's definitely not 15. It's more along the lines of let's say 8, just about 8. 8 works for me. Alright, and that doesn't look like much now, but that's going to be the top of our pick. Now I'm going to delete these measurements because they're not going to change, and they're kind of getting in the way. We can also delete these reference lines we made. You could keep them in, it wouldn't really affect it in the end, but I like to work with as clean as possible. Alright, so now we're going to find that center line again, which you notice here, it kind of gives you that dotted line, leads you right to it, very nice. And now making a perpendicular line to it, you see that 90 degrees. We're going to go down to the length of the pick, which I measure to be 27.5 millimeters. So if we just type that in, it'll continue it down. And now that gives us a really good reference line to make more arcs with. So again, 3-point arc. We're going to go from this to this. And we're just going to try to match it as close as possible. I mean, there's math I could do to figure this, but honestly, I'm just going to kind of eyeball it. We're not looking for perfection, we're just kind of looking to get the idea down. That's not too bad. I think that's pretty close. Let's finish sketch. And then it gives us the option to extrude, which is like what gives it its thickness. It makes it 3D. And we know it's all helps if I select the two paths there. We know it's a 1.5, it says right on the pick. And yeah, that's what our pick's gonna look like. It's pretty accurate, I think. One thing I didn't do is put bezels. We could still do that with this fillet tool. And trying to get a look of how they did this on this pick. It's kind of interesting. You can feel it more than you can see it, if that makes sense. Like, it's a very, very minute thing here. Maybe like half, maybe less than half. Let's try 0.33, just all around. So you could just hit that, and then if you hit shift and click on the other one, it'll add all of them, like whatever you pick. And it's only bezeled on like one side, I think. It's kind of hard to explain without like actually touching the pick. It's a little bit different, but I mean, it's good enough for a Mark 1, you know? Alright, so now the next step would be to prep it for 3D printing. So I'll see you in 1 second with that software. Okay, so this is kind of a fun part of the process of 3D printing. This is a program called Cura by Ultimaker. It is totally free. It is what's known as a slicer software. Basically, it takes a STL file, which is a 3D image file, which is what we made on Fusion 360, and it lets you import it in, as I will do now. Save it 3D objects, pick V1, and as you can see, there's our pick. Now, what this lets you do, I mean, I can move it around on the print bed. I have this custom, the print bed is like customizable to your own printer, so it matches the exact size and specs of my printer. You can like readjust like shape, sizing, scaling, anything like that. It has a bunch of those like kind of tools, but we don't need any of that for this. It's a pretty simple print. Okay, we are going to, there's some adjustments I would like to make, such as infill density. So the original pick is extraordinarily thick and strong. So what infill means is it wants to print everything like it's a shell, like it wants to make the shape. And infill is how much to actually fill in the inside of it. The more you do, the longer it's going to go, but like the more infill you have, theoretically, the stronger and tougher it's going to be. So like, it's a pretty small print, and I'm only going to do one, so why not go 100%? It is going to add print time for sure, and this isn't normally something you use, but we might as well go 100% on this. There's some things we can adjust, like temperatures of the printer. I can also adjust those on the printer, which is what I prefer to do. We shouldn't need any skirting or anything that's like additional support, because it's, you know, not a very big print. There's not it's a relatively flat object. So I think we should be fine, just as is. I have pretty basic settings on. I think the best thing we can do is now just hit slice, which basically will process a bunch of, yeah, it's only a 6-minute print apparently. It uses a gram of filament. So now we can save that to my other SD, H, movable drive H, which is a micro SD card, which fits on my printer. and then we can give it a print and see how it goes. So stay tuned for the printing process. Okay, so now we have our picks. It's finished, and so just for reference, the original and what I made. It isn't very see-through as we had all the infill, even though it was see-through filament, but there is some big differences, I will say. This one, the original, being made of acrylic, it is a lot sturdier. It's a lot more rigid. Whereas this can be bent for sure, definitely, no problem. It does have a lot of strength if you do bend it, which is kind of the appeal. One of the appeals of the PETG filament we used for this. Perhaps a different infill shape, like maybe triangle or something else. I used grid, which is the standard, but I could edit that. Maybe that would give me a bit more stiffness. That'd be something to try in the future. Maybe I'll make a bunch of different ones at different settings and kind of compare at some point. But overall, I mean, shape-wise, we designed it well. It's a good design. It's slightly, it's just about right. That's a little smaller. Like maybe maybe if I were to put it like 9 instead of 8 when I first made the top of it, maybe that would fix it. But overall, it's very similar shaped. And it's not too different with feel. It is nice and smooth. I could probably smooth it out a little bit more on the bedside with a, well, either side. I think it's actually top side. I could probably smooth that out. Just take a little bit of sandpaper. But overall, it's not bad. I don't think it's going to hold up to as many uses, but it's not bad. It feels nice in my fingers. It definitely feels really similar to this. Has all the nice points on it. The bevel didn't show through as much, but that's okay. Honestly, I'm not certain that it makes that big of a difference. And, like, it definitely doesn't feel the same on the edges, but it's not that far off, and I don't think it's that noticeably different. I guess the only way to know is to grab a guitar and compare. Alright. So I figured acoustic might be a good way to kind of abuse this pick a little bit. The strings on this particular one are a little bit beefier than a lot of my electrics right now. And just tuning it up, I can already see that it's kind of to see, but it is fraying a little bit already. So hopes are not very high for this pick, unfortunately. But I mean, it feels decent. It feels decent as a pick. Like, I mean, for something that cost me nothing to make, I guess it's cool. Just the structure of it, based off the way I made it, like I said earlier, maybe I can fix it. It kind of reminds me of like those nylon picks, those super thin nylon picks for like classical guitar. Oh, yep, I can feel the binding of it coming off. Oh no. Oh. Yeah, that's not good. That's not what you want. Oh no. Oh, that's so sad. I'm gonna play with it anyway, I guess. That was a bad note. if I just rip it off, you can kind of hear it crinkle a little bit. It's not what you want in a pick. Now I'm trying to be gentle with it. But it feels really nice though, other than, it's falling apart. And you can use the, so one thing I like about the other one, especially when playing on electric, which now I don't know how this thing would hold up to electric strings either, is you can kind of turn it and use the other points on it if you want. Oh, it's falling apart good now. Oh man. I don't know if I'd do it with this one because, oh, it's just shreddy. Oh no. It's just getting layers off it now. I guess we'll just play until it's gone. Just trim pick it until it's dead. Viking funeral. Oh, this poor pick. He's not doing so hot. So, I guess the moral of the story is you can make picks, but at least the way I did it, they're not very durable. And that's going to be a problem. Oh. It just keeps getting smaller. So yeah, I think I'm gonna call it, because this thing, at this point, I think I could probably, like, fold it in half. Oh no. You shouldn't be able to do this with your picks. And the other way? Oh man. I will say it's pretty tough in that way, but not structurally. Its tensile strength is pretty crazy, but other than that, ooh, not what you want. So I'm gonna say this experiment, as it was conducted, was a fail. Maybe I'll try altering. Like, there's some edits I could make in the printing process. Might make it a little stronger. Maybe I'll get some different filament, because maybe something is better suited for it. But for now, that's where we're going to leave it. thank you for watching this. I hope you learned a little something. I sure did. Yeah, and don't make picks out of that. I mean, it's fun, but don't use them, I guess. They're not very functional. Alright, thank you for watching. If you have any questions about anything I did in here, let me know. I'll monitor the comments and try to help you out. If you have any questions about guitars, 3D printing, any of that. Thank you.